All right. Good afternoon, everybody. We're going to be going over 3.8, the tangent function, day 2. So yesterday, we looked at our tangent function. We built it from the unit circle and then looked at some key characteristics of our tangent function. And so today we are going to be taking some of those key characteristics and our transformations to graph our tangent function. Same exact transformations that we have used all year: horizontal dilation, horizontal shift, vertical dilation, vertical shift. And we're going to be taking our parent function of tangent, which we have pictured here, and applying our transformations to our to that parent function so we can get our new graph. So again, we have our parent function. So this is our parent function of tangent. And when we go to graph, so this is parent function, tangent of x, is this function here. And when we go to graph a graph of tangent, we are going to graph the main period of tangent, which is going to be between these two vertical asymptotes with those 3 points forming our graph. Now, when we created the tangent graph yesterday from the unit circle, we had obviously a whole lot more points. Between each vertical asymptote, there were 1, 2, 3, 4, 5, 6, 7. I think 7 different points between each vertical asymptote. And we're only going to be using these 3. We're going to be using these 3 because when we have our vertical asymptotes, once we have a vertical asymptote location, and we can see this at negative pi over 2 and pi over 2, just like sine and cosine, we can cut the that period, because this is our period of pi, we can cut that period into quarters. So we cut it in half, right? And that one right in the middle is going to be on the x-axis. And then we can cut that again in half. That would be at negative pi over 4. And that point is going to be down at negative 1. And then we cut the other one in half at pi over 4, and that one will be up at positive 1. And so we're going to just do that cut it in half that we've done before. So we'll have those quarters of the period, which will actually then create those 5 key locations like we did with sine and cosine. And if we think about those 5 key locations, that would be vertical asymptote, first point down at negative 1, second point at the x-axis or at 0, third point up at positive 1, and then vertical asymptote to finish off the period. So that'd be 1, 2, 3, 4, and 5 key locations, just like we did with sine and cosine. So again, we will be graphing that main period. We'll be starting by finding our vertical asymptotes and putting everything in, and then applying our different transformations. So let's go ahead and talk about our different transformations again. Now this is out of order. What would be the correct order? What's the first transformation we do? Horizontal dilation, right? And then after that, and then, so that is again our correct order of, I put them in this order as bullet points, but I think I put it in that order because that would be our A, B, C, and D. I did it alphabetically with the different letters that are representing those different parts, but it does actually get us out of order of our actual order of the transformation. So we just have to remember that that's our order there. So our horizontal dilation, we're going to be doing a factor of 1 over b, which that's what we've been doing this whole time. We said yesterday that we're kind of relating sine and cosine. Sine, when we did horizontal dilation, sine and cosine, we did 2 pi over b. Well, this time, since our period for tangent is pi, instead we just have pi over b for tangent. So a little bit different based on the period that we have. Now, at this point with our horizontal dilation, we are also going to find where are our vertical asymptotes. So let's go ahead and write that down. We will find our VAs at this point. Now, where are the vertical asymptotes on our parent function of this main period that we're graphing? Where are those vertical asymptotes? So more or less plus or minus pi over 2, right? At the positive and the negative pi over 2. So we're going to take that plus or minus pi over 2, and we're going to multiply that. This is going to be our vertical asymptotes. We're going to multiply that by the 1 over b factor. So 1 over b, the reciprocal. Remember, that's the reciprocal of whatever our b is. Maybe make a note of that to remind ourselves that is the reciprocal of whatever b is. Now, it's important to note b is not the period. I was just been going through and grading tests from Wednesday, and there's been a few people identifying and saying b, the value of b is the period, and you need to remember it's not. It's either pi over b for tangent or 2 pi over b for sine and cosine. So I have to make sure that we pay attention to that. All right, so that's what we're going to do first with our horizontal dilation. We're going to find those vertical asymptotes and then cut that period between the vertical asymptotes into quarters, half and then half again. And then second, we'll do our horizontal shift of C units. Remember that we also need to factor out the b, just like we did with sine and cosine. It's also called the phase shift, same as sine and cosine. The next, our vertical dilation by a factor of a. So we're just going to multiply all our y values by whatever our a is, whatever our y values multiplied by a. And then vertical shift of d units up or down. So let's go ahead and try this out with our first problem right here. So again, looking at this problem, before we can do anything, what is the first thing we need to do? Looking at the middle right here inside of our function. Factor out the 1/2. So let's factor out the 1/2. So y equals -3 tangent of 1/2. Factoring out that 1/2, what would that leave me with? X minus not pi over 2, if I factor out that 1/2. Let's see. Remember how we do that? We take our c value, and what am I going to multiply my c value by? The reciprocal, so 2 over 1. What does that give us? 2 pi over 2, or just pi. So we have minus pi in here and plus 2. Okay, let's go ahead and identify our different transformations. Starting with our horizontal dilation. So horizontal dilation, and we said that we're going to find our vertical asymptotes. But what did I say we are going to do to find our vertical asymptotes? What did I say up there? We're going to take plus or minus pi over 2 and do what? Which in this case, we kind of already did that, 2 over 1, right? Happens that we get that same multiplication problem we had when we factored out. Where are our new vertical asymptotes? What happens to the 2's? What are we left with? Plus or minus pi, so positive pi and negative pi. So on our graph, let's go ahead and mark that. At negative pi, we're going to put this in. You can do it lightly because this is actually going to change. This is where we're starting. All right, and then we also need, so that's our main period that we're going to be looking at. We're going to go ahead and cut that into quarters. So what is halfway between negative pi and pi? at 0. And if we look at our parent graph, that is going to be 0. So we're going to go ahead and just put a point there. What is halfway between 0 and negative pi? Where is our point going to be at that location? At negative 1, right? We start negative 1. And then where's our last location? And at what y value? Positive 1. And so let's go ahead and dot in our parent, well, technically not the parent function, but our starting function here. It's not our ending location because we have other things that we need to do, but that's where we're going to start. All right. Next, we have our horizontal shift. What is our horizontal shift? What's our horizontal shift, guys? Pi. Remember, that's the value that we got after factoring out. So it's pi, but pi in which direction? To the right. All right, so we're going to go ahead and take all of that, including our vertical asymptotes. Everything's going to shift right by pi units. Well, based on the grid, how many spaces is that for pi? 4 spaces, right? So we're going to go ahead and just move everything 4 spaces, including my vertical asymptotes. So vertical asymptotes get moved. And all our points get moved. And let's dot in that graph. All right, next is our vertical dilation, right? So what are we going to do for our vertical dilation? By the a value, and what's our a value? -3. So all our y values are going to get multiplied by -3. So that's not going to affect our vertical asymptotes. Those aren't going to change. But the 3 points are going to change. So let's look at our 3 points here. We're at the purple ones. The red ones got shifted, so now we're looking at the purple ones. Starting with this one here, -1. Where would that go then? +3. So we multiply by -3. What about 0? Still is 0, right? 0 times anything is 0. What about +1? Become -3. So that made a reflection, right? So everything got reflected across the x-axis. All right, we are almost done with this graph. Let's go ahead and shift everything. Where are we shifting our points? Up 2. Again, not going to affect our vertical asymptotes, just the 3 points. So I shift everything up 2. And this is I'm doing from my green points. So that's where I'm at. And that should be my final location for this one. So I make it nice and solid. If you want to darken in your vertical asymptotes as well, that's where our vertical asymptotes are going to end up, is at those locations. Those are the final locations of our vertical asymptotes. All right, and that is our final graph for that one. There is one other thing that we're going to do with this problem, but that is graphed. Any questions? So again, we're utilizing our same transformations, same exact transformations that we've been using since, what, like September, right? You've also used them in previous years. Horizontal dilation, horizontal shift, vertical dilation, vertical shift. Those are our exact same transformations that we've been doing all year. We're just now applying it to our tangent function. All right. So one thing that is often asked of us that I don't have in the notes here, so we're going to go ahead and add it in, is often it will ask for an equation for the vertical asymptote. So we're going to go ahead and figure out what would be an equation for our vertical asymptotes. And this is going to use the idea that we did yesterday when we talked about our key characteristics. We're going to use this kind of idea here, where we had this pi over 2 plus pi n, where n is an element of the set of integers. And we're going to use this to find out an equation for all vertical asymptotes. Because this is how we would represent all the vertical asymptotes, because we have an infinite number of solutions, but they're all equally spaced apart. So we can go ahead and identify where that would be. So what we are going to do, actually I'd like you guys to think about this. Which transformations affected our vertical asymptotes? Think about that for a moment. Which of these 4 transformations actually affected the vertical asymptotes? Which 2 transformations affect our vertical asymptotes? Horizontal dilation and horizontal shift. Did the vertical ones do anything to them? No, the vertical dilation and shift didn't touch them at all, right? If I stretch out a vertical line, it's still a vertical line. If I shift a vertical line up and down, it doesn't really move anywhere. So what we are going to do is we're going to take those transformations and apply them to the kind of equation that we came up with yesterday. Now I can apply them just in the order, do horizontal dilation, then horizontal shift, or we can also actually set them up as an equation, which I want to show you here. So this is going to be how we can find the equation. So we're going to use this little space that we have here. You should hopefully have a little bit of space too. We're going to use this to find an equation for all vertical asymptotes. Now, where do we get the information that does the horizontal transformations, the dilation and shift? What part of our equation is that information gotten from? Inside the parentheses. So what we can do is we can take this inside of our function, and theoretically we can use either non-factored or factored form. I'm just going to use the factored form. But we're going to take this inside, that is where our horizontal dilation and horizontal shift information comes from, and we're going to set it equal to that phrase that we got yesterday. So I'm going to take the inside. Again, I'm just going to use the factored form. You can use the unfactored form, but I'm going to use the factored form. And I'm going to set it equal to that vertical asymptote kind of equation that we had yesterday. The pi over 2 plus pi n. Sometimes they use k instead of n. It means the same thing, where n is an element of the integer set. And then we're just going to solve for x. And once we have solved for x, that equation is what we want. So let's think about that. How can I solve for x on this equation without distributing? I don't want to distribute because I already factored out. How can I solve for x? How would I get rid of the 1/2? Divide by 1/2, but how do I divide fractions? So in the same sense, I'm multiplying by the reciprocal here and over here. Wait, isn't that what we just did in the horizontal dilation? We multiply by 2/1, right? So it's like we're applying our horizontal dilation here. Multiplying by that reciprocal. That will get rid of the 1/2, and I'm left with x minus pi. What happens when I multiply 2 into each of these? What am I going to get on that right side? We've already done this like twice. What is pi over 2 times 2? Just pi, and then what else would I have? 2 pi n. So the length of our period is no longer pi, it's 2 pi. Vertical asymptotes are 2 pi apart. All right, we're almost there. What do I do to get x by itself? Just add pi to both sides. So I'm going to add it here. I cannot add it to the one with the n because that's a variable. It's not a like term. So I'm going to be left with x equals pi plus, or no, how many pi's? 2 pi plus 2 pi n. And then comma, n is an element of the set of integers. And that would be my equation for all vertical asymptotes. So all we do is we take the inside of our function, the stuff that affects our vertical asymptote, horizontal dilation, horizontal shift, and we set it equal to this. And if we think about this, we did do our horizontal dilation. I already mentioned this one, but multiplying by the 2 over 1 is what we did with the horizontal dilation. And then adding pi is the same as saying I'm shifting to the right pi. Right? If I'm going right pi, that's like I'm adding pi. So it's the same exact things that I have here, is just in an equation form down here. Also, we can double check that this makes sense in our graph. So this is saying all vertical asymptotes happen at 2 pi. Do we have a vertical asymptote at 2 pi? In our final graph, did we have a vertical asymptote at 2 pi? And then are all the vertical asymptotes 2 pi apart? So this would be like 2 pi n, so I could have 2 pi times -1, so it'd be like minus 2 pi. Well, that'd be at 0, which I have a vertical asymptote. Or if I say plus a 2 pi, well, that would be over here at 4 pi, which would make sense. So we're that 2 pi apart. So in a sense, we could technically get an equation just by looking at the graph, but we can also solve it this way if we don't have a graph. So I want you guys to go ahead and try problem 2. Try problem 2. Go ahead and graph it. Go through your different transformations and graph your graph. And then see if you can get that equation for all the vertical asymptotes. All right? So take a few minutes and try that out. Okay. Let's go ahead and go through this one. Sophia S., what would I do first? And what would we do for our horizontal dilation? And what is this finding for us? All right, so what are our new vertical asymptotes, Sophia? Plus or negative what? Pi. Okay. I didn't hear the pi. All right, let's go ahead and draw those in. So there's nothing to factor out on this one, right? Because there's no bx plus c, so we can just go straight forward. Daniela, what would we do next? Vertical dilation. All right, what am I going to do for vertical dilation? All right, so what points? Oh, I forgot to do something beforehand, guys, before we can do this. I forgot to put in our 3 points. Let's go ahead and do that. So that should be halfway at 0, then halfway here at -1, and then up at +1. I forgot to do that. All right, now that we have those points in, Daniela, what am I going to do with that dilation? Which ones are those going to affect? Good. Good. And is there any other transformation, ladies and gentlemen? No, so that is it. I can go ahead and just graph that. And we are done. That was easier. Okay, let's see. Let's do that equation. Equation for VAs. All right, so we know we're setting it equal to pi over 2 plus pi n. N is an element of the set of integers. What am I going to set that equal to? Tyler? 1/2 x. So the inside, right? So I'm going to do 1/2 x. All right, what do we do to solve that? Nathan, how am I going to get x by itself? Divide by 1/2 or multiply by its reciprocal, right? So I'm going to multiply by the reciprocal. So that will leave us with just x. So what is x equal to, Brandon? What would x be equal to? Plus? Pi n. N is an element of the set of integers. And there we go. That is done. All right, go ahead and try problem 3, please. Try problem 3. As you're doing problem 3, I'm going to go ahead and pass out your homework. All right, let's go ahead and look at this one. Let's start with our, well, what are we going to start with? Dean, what do we need to do first? Okay, let's go ahead and do that. So y equals -1/2. Tangent, factoring out my pi, what would I be left with, Dean? X plus 1/2. Good. So if we didn't see that, that would be pi over 2 times the reciprocal 1 over pi, which would be, well, pi's cancel, leaving us with 1/2. All right, Ava, what do we do next? Good, so we're finding those vertical asymptotes, right? So for our VAs, our plus or minus pi over 2 times 1 over pi, the reciprocal. So what's our new vertical asymptotes, Ava? Good, 1/2 and -1/2. Let's go ahead and put those on our graph. 1/2 and -1/2. Okay, and let's mark in our 5 places. So halfway, halfway again down at -1, halfway again at +1. Our nice, lovely tangent graph there. All right, Zach, what do we do next? So 1/2 to the left. Okay, so let's move that 1/2 to the left. So that would put me at -1 for my vertical asymptote. So that's moving 2 spaces for everything. So moving 1/2, moving 1/2, moving 1/2, and moving 1/2. Okay. All right, Ellie, what would I do last? And what am I going to do for my vertical dilation? And what am I going to multiply -1/2 to? The y values, right? So let's go ahead and do that. So I have -1 times -1/2 would put me at +1/2. 0 would still be 0. +1 would now be -1/2. So now I should have that, and there's no other transformation, so we can go ahead and fill in our tangent. And I could theoretically draw some more tangents there. I could fit in 3 other tangent functions. If I wanted to, I could have another tangent function going down like this here, and another one going down like that there if I wanted to. You do not have to. We are graphing again just that main period, but we need to remember that this is periodic, so this is not the entire graph. There is going to be more of this on other sides of tangent. This is not the entire graph. This is just the main period. All right, let's go ahead and get that equation for all vertical asymptotes. So let's see, our pi over 2 plus pi n. N is an element of the set of integers. What am I setting equal to that equation? Jathan, what am I going to set that equal to? What was that? Just 1/2? Okay, so there is an x plus 1/2, but there's more than that. What else? The pi as well. So it's the entire inside of the tangent function. All right, we're going to go ahead and solve that. So how would I solve this? Isabel, what would I do first to solve? Multiply by the reciprocal, and what is our reciprocal? 1 over pi, same reciprocal I used in my horizontal dilation. 1 over pi. So that's going to leave me with x plus 1/2. But what am I going to get when I multiply that 1 over pi in? Damien, what is that going to leave me with when I multiply 1 over pi in? If it helps, you can write it out. 1 pi over 2 times 1 over pi. Correct. And then on the other one? 1n. Good. So I would have just 1n plus n. And then, Jacob, what would be the last thing to solve for x? How would I get x by itself? Our simple equation, right? What happens to those halves? On both sides, right? What are we left with on the right side? So then our equation is x equals n, where n is an element of the set of integers. Okay, before we go, I wanted to just mention something on our worksheet that I handed out. Just looking at the time, so I just want to mention this. So if you look at this real quick, notice problem 1, problem 2, they're saying write an equation that represents all asymptotes of the graph. That's what we've been doing, right? Finding that equation for all vertical asymptotes. Now, 3 and 4 is worded very strangely, so please don't pack up yet. It says, what is the slope of the terminal ray of the angle? That is actually in yesterday's notes. If we go to yesterday's notes, at the top of our notes, very first thing that I talked about, notice right here, the tangent is the slope of the ray. So when they say find the slope of the terminal ray, it's just asking you to state what the tangent of that angle is. Okay? It's a weird, interesting way of just saying what is the tangent of that angle. Okay? And then 5 through 7, they're asking for tangent as well, and then you're graphing. So it's all stuff that we've seen from yesterday and today. All right, everybody, have a fantastic day. I'll see you on Monday.